Okay, I think we're ready here. We're going to do function, composition, and decomposition, which is, well, composition is sticking one function inside of another, and then decomposition would be the reverse of that. But before we do any problems, let's go over the notation here. So whenever you see this open circle like this FOG, some people say fog to remember it. It's not actually an O. But that open circle right there, that's not multiplication, that's composition. And this is what it means. It means f of g of x. And then you could do this the other way too. You could have g of f of x. So this is the same as that. Do not multiply. We'll do some multiplication later so you see the difference. But don't mix up composition with multiplication. That open dot is composition. So good. Let's start with some linear compositions here, meaning I'm just going to compose linear functions. All the functions on this page are linear. Good. Let's start here. So it says find f of g and g of f. So we're going to go both ways on these things. We want to check both ways on these things. Let's see. I'll scoot over this way a little bit. Good. All right. Start with f of, and then I'm going to color code here to show that we're putting g into f. We are putting g into f. So I'm going to rewrite f, but everywhere there's an x, I'm going to put a g of x. So f is x plus 3, but instead of just putting x plus 3, I'm going to put g of x plus 3, right? That's what it means. And then what is, can we see all this? Yeah, we can see all this. What is g of x? Well, g of x is x plus 4. And then we have this little plus 3. And the only thing we can simplify here is this 4 plus 3. So that equals, final answer here is going to be x plus 7. X plus 7 right there. Good. And here's how you're going to check this. So just FYI, throughout this video, I'm going to be going back and forth between the algebra and the graph on Desmos. So I'm going to do this every problem, which may feel like it slows down the video for you, and you can skip ahead just to see the answers. But here's what I want to do. I'm going to switch over to Desmos right now. And right here where it says f of x, I'm going to type in what my f of x is, right? So here my f of x is x plus 3. I'm going to type in x plus 3 here, and I need to turn this on. So there we go. This purple graph is the graph of x plus 3, and then my g of x is x plus 4. So x plus 4 right there, right there. All right, so the purple is your f of x, and your blue is your g here. And now what you'll see here, I have h of x equals f of g of x, right? So Desmos is going to do this automatically, and that's going to be the white graph. That'll be the white graph. So let's see, if our answer is correct, it should be the same as the white graph. So I'm going to go down here. I put A for answer, and our answer is x plus 7. Our answer is x plus 7. And if I turn this on, we're actually not going to see another graph appear because it is the same as h. If I toggle these off and on, you'll see that they overlap each other. Now, if I actually click it, it'll highlight the graph, and we can see that sure enough, this is the correct answer. So good, we got f of g correct. Now, we also need to do g of f. We also want to do g of f. So do I want to do this below it or to the side? Let's do it below. So we want g of f of x, which means I'm going to copy down g, which is x plus 4, but I'm going to put f of x plus 4, f of x plus 4. And I guess it would help if you could see the original problem, but I don't know if this is going to fit. Let's see, can I fit this right there? Ooh, yeah, maybe. Why don't we put a little line down the middle? Line down the middle right there. Good. Yeah, let's put a little line. Okay, that's nice. And then this is going to equal, what is f of x? F of x is x plus 3. And then plus 4. And then 3 plus 4, again, is going to be your x plus 7, x plus 7. So there you go. They happen to be the same here. That is coincidence. Don't assume these are all going to have the same answer. They most definitely will not. But let's see this. Let's see this. We'll switch back to Desmos. And that's my k. I'm using k here. It's just what I felt like using. That's not a thing you have to do. And let's see, if I turn on g of f of x, you'll see we get the same x plus 7. X plus 7 is the same as g of f of x, right? So we did, in fact, get this right as well. All right, good. So here we go. Let's go here now. And then, all right, we'll start with f of g, so f of, and then g. So we copy down f, and everywhere there's an x in f, we replace it with g, and we will want parentheses here. So that's going to be 2 times g of x. And let's see, what is that? So that's going to be 2 times g of x is x minus 7. Is x minus 7. Now we want to distribute this. We want to distribute this 2, and we would have 2x minus 14. We'd have 2x minus 14. And let's check this. Let's see if this is right. So our f of x here is now going to be 2x. 2x. Our g of x is x minus 7. X minus 7. Let's hide that and replace it with 2x minus 14. Okay, so here the blue graph is g. Whoa, whoa, whoa. What is going on here? I said 2x minus 14. The purple graph is f, the blue graph is g, and then if I turn on this h right here, that's the composition. So the white line is the composition f of g of x, and let's see if that's the same as our answer. Turn on our answer, and we see that there is no difference. So good, we got that graph correct. Now let's do it the other way around. We want to do g of f of x, which is going to equal f of x minus 7. So again, all I've done here is I've copied down x minus 7, but I've replaced the x with an f of x, and f of x is 2x minus 7. And there's nothing you could simplify here, so for one final answer with all black, there we go. There we go. That's the answer right there for g of f. All right, good. Let's square that up, and let's go check this. Let's check this. So 2x minus 7 should be our other composition, 2x minus 7. Let's turn these off. Okay, here is the accurate composition, g of f of x, that's the white graph, and let's see if b is the same. Boom, and sure enough, we get matching graphs. So yes, our compositions are working. Good. All right, and let's go to this one now. All right, I'm going to skip out on color coding just to speed things up here, but f of g of x would be, I copied down f, but I replaced x with a g of x minus 1. What is g of x? It is 5 minus 6x minus 1, and then 5 minus 1 is 4, so I can leave this as 4 minus 6x, just like that. Let's do them both and then check them both. So we also want g of f of x. This will be the other way around, and this will equal, all right, that's going to be 5 minus 6 f of x, which equals 5 minus 6. Now plug in f of x. Ooh, I'm running off screen a little bit here. Come back. F of x is x minus 1. Now you need to distribute this negative 6 right here. Distribute that negative 6, and that'll give us 5 minus 6x plus 6, and 5 plus 6 is 11, so 11 minus 6x. Good, right there. We can see all that. All right. So our x is now x minus 1. Our g is 5 minus 6x. And then, all right, so here's the composition. Ooh, it's right up against it, the white one. Zoom in a little bit. And then let's type in, what's our first composition? 4 minus 6x. 4 minus 6x. And if we turn that on, we see that it does line up. So that's good. That one is correct. Here is g of f of x, the other way around. And our answer for that is 11 minus 6x. Minus 6x. And yep, those are the same. So we're good. That worked. Last linear example here, f of g of x is going to be 8 g of x plus 9. Substitute in g of x, which is 9x minus 8 plus 9. We want to distribute that 8, distribute the 8. That would give us 72x minus 64 plus 9, and negative 64 plus 9. What is that? What is that going to be? 55. I'm going to double check that. Negative 64 plus 9, and we're good. Negative 55 right there. So, good. All right, that's f of g of x. Now let's do g of f of x. G of f of x. We'll squeeze in next to it. G of f of x, g of f of x. And that's going to equal 9f of x minus 8, which equals 9. And what is f of x? F of x is 8x plus 9, 8x plus 9. 8x plus 9 minus 8. Distribute the 9. 72x plus 81 minus 8, which is 72x. 81 minus 8 is going to be 73. All right, so here's the whole thing. Let's check those. F is 8x plus 9. G is 9x minus 8. X minus 8. And our answers here, for the first composition, we had 72x minus 55. And we have 72x plus 73 right there, like that. Okay, so here we go. Our purple is our F, and our blue is our G, as always. And here is the first composition accurately. And then let's check our answer. And we have the same line. Good. Here is g of f of x. And let's check our answer. And we have the same line. Awesome. That worked. Very good. Can we see all these at once? There we go. Look at that. Look at that. Okay, so those are 4 linear examples. Let's bump it up to quadratic compositions. So more specifically, we're going to have 1 linear and 1 quadratic, but the compositions will end up being quadratic in the end. So let's go. I'll bring back the color code. Do I want to bring back the color code just yet? Not yet. We're going to do f of g of x first, all black here. And so this will be f, which is 5x, so 5g of x. And then what is g of x in its entirety? That is x squared minus 9x. Distribute the 5. And that is 5x squared minus 45x right there. In fact, I do just want to check this right now before we do it the other way around. The other way around is where we're going to see a big change in these types of problems. But let's start checking this out first. So our f is 5x, and our g is x squared minus 9x, like that. Okay, and then we're not using that right now. This is supposedly 5x squared minus 45x. All right. Oh, let's zoom out here so you can actually see. There we go. So we are dealing with a quadratic this time. We have our linear, our f is linear, our g is quadratic, and the composition here, f of g, is quadratic. It's a much steeper one. It's that white one. And is that consistent with our answer? Yes, those are in fact the same. thing. So we got it. Good. Let me just zoom in, zoom way in. Yeah, we're good. We're good. That's it right there. So cool. Cool. All right, hide that. Let's do it the other way around now. And here, actually, I wish I really would have written the problems down twice. So here's what I'm going to do. Actually, I don't want to delete this because, I mean, heck, we did the work. But I'm going to put that down there at the bottom because we're going to need some fresh space here. We're going to need some fresh space for the other way around. So now we want to do g of f of x. And I'm going to color code this so you see this time, because notice in G, what we haven't dealt with yet in this lesson is G has two x's. G has two x's. We need to put f of x into both of those. So that will be f of x squared minus 9 times f of x. So just as we have two x's here, we now have two f of x's there. We need to plug in for both of them. Equals, all right. And what is f of x? It is 5x. F of x is 5x, just like that. Great. That looks good. Okay. Equals 5x squared. That is 25. Make sure you square the 5 as well. That's 25x squared minus 45x right there, like that. Okay. Let's check that. So this would be the second composition, 25x squared minus 45x. And, okay, here is the composition right here. Very narrow parabola here, that white one. And then is that consistent with our answer? Yes, those are the same graph. So we got the composition. Very good. And then let's go ahead. Now, just FYI, pay attention that these got flipped around. That's f of g right there. That's g of f right there. So, all right, next one. Right there. There we go. All right. So, easy one here is f of g of x. This will be straightforward. That's just going to be g of x plus 4. G of x is x squared minus 11x plus 4. And that is it right there. So there's nothing that can be simplified, nothing that can be combined. That's it. Let's check it. That's f of g of x, and here's our answer. We're good. All right, now the fun one. Yes, okay. This one is going to require a lot of algebra here, a lot of algebra coming your way. So we want g of f of x, g of f of x. Everywhere there's an x in the g, you need to put an f. So that means we're going to have x squared minus 11x. And what is f? F is x plus 4. F is x plus 4, just like that. Great. Okay. Now, here's the deal right here. Let's talk about this. This is a binomial squared. This is not x squared plus 16. This is x plus 4 times x plus 4. You got to do this. Minus, we'll distribute the 11. That's 11x minus 44. Distribute the negative, right? That is a negative 11 right there. So, good. You need to FOIL this. And I will go in detail right now. This is the one and only time I'm going to go slow on this video. But maybe you've heard of the acronym FOIL, first, outer, inner, last. So first we multiply the x's, and that is x squared. We then multiply the outer, that is the x and the 4. X times 4 is 4x. We then multiply the inner pieces. 4 times x is 4x again. That will always be a duplicate. These will always be a duplicate when you're squaring a binomial. And then last is 4 times 4. And 4 times 4 is 16. Tag on the minus 11x minus 44. All right. And then our last step here is to combine like terms. So those 4x's can be combined with the minus 11x, and the 16 can be combined with the minus 44. And this gives us an answer of x squared. 4 plus 4 is 8, minus 11 is negative 3x, 16 minus 44. I don't trust myself with that one. That's going to be minus 28. Minus 28. And that right there, hopefully, is the answer. So let's check that one. X squared minus 3x minus 28. All right, here is the accurate composition. Oh, look at that. All it is a horizontal shift. That's cool. And here's our answer, and we're good. They are the same. Look at that. That's awesome. Okay. Very good, very good. F of g of x would be 10. I'm going to start skipping steps here and just plug in the function right away. I would then distribute this 10, and that would give me 10x squared minus 90x minus 100. Let's check it. So f is 10x minus 7, and g is x squared. 9x minus 10. And then let's check the first composition here. We got 10x squared minus 90x minus 100. All right, good. That fell off a little bit, but I'm not gonna change this now. So the white one is the composition. That's a pretty steep, long parabola there. And then let's check ours, and we have the same thing. Very good. All right. Main. Now for g of f. So g of f of x is going to equal f of x squared minus 9 f of x minus 10. So what I'm doing is I'm putting parentheses everywhere there's an x, because I'm going to plug f of x into all of those. F of x is 10x minus 7. And then, good. So I'm not going to show the whole foiling binomial squared. If you don't know how to foil, if you don't know how to square binomial, pause, go practice that. But this right here, 10x minus 7 squared, is going to be 100x squared. 100x squared. Minus 70x, which is minus 140x. 7 times 7 is 49. Distribute the 9, that's 90x plus 63 minus 10. Can we see all of that? Yeah, there we go. There it is right there. And then we combine like terms. So we got a minus 140x, a minus 90x, and then as far as constants go, we have a 49, 63, and a negative 10. Combine those. We would have 100x squared. Negative 140 minus 90 is negative 230x. And then calculator, here we go, 49 plus 63 minus 10 is going to be 102. This is going to be a very narrow parabola. Here is the actual one. There it is right there. And then is our answer the same? Yes, yes, our answer is the same. Very good. Starting with f of g. I'm just going to plug in g right away to that x. That's going to be 2x squared minus 3x plus 4 plus 3. Distribute this 2. Distribute the 2. That'll be 4x squared minus 6x plus 8 plus 3. And the only thing to combine here is the 8 plus 3, which is 11. Which is 11 right there. Okay, here's our f and g. Here's the correct composition. Here's our answer. We're good. We got it. And now for g of f. G of f. G of f is going to be 2x plus 3 squared minus 3 times 2x plus 3 plus 4. If we FOIL 2x plus 3, 2x plus 3, that's 4x squared plus 12x plus 9. Distribute the negative 3, that's minus 6x minus 9 plus 4. Distribute the 2, that's going to be 8x squared plus 24x plus 18 minus 6x. At the end here, negative 9 plus 4 is negative 5, so we could do that right away. And then we have a 24x and a minus 6x and 18 minus 5. Combine those. And we have 8x squared plus 18x plus 13. Okay, there's the composition. That's g of f of x right there, and here's our answer. We're good. We got it. Okay, so here's the quadratic examples. There's the top two. Again, pay attention that g of f ended up being on top and f of g ended up being on the bottom there because g of f's, those were longer. We did those second. And then here's the second two examples in their entirety. So, and those are all confirmed correct via Desmos. All right, let's do some exponential compositions here, meaning I don't know if the final answer for both of these is going to be exponential, but there's exponentials involved, so that's why I called it this. Starting here, let's start with f of g. So f of g of x would equal e to the x plus 7 squared plus 1. And good. This requires properties of exponents, right? Properties of exponents, when you have a power to a power, you multiply the exponents, and you will need to distribute this too. This ends up being distribution. So this is e to the 2x plus 14 plus 1. All right, that's the first one. Let's see, maybe both of these are small. Let's see if we can fit both of these right here. And then g of f of x, g of f of x, g of f of x. That would be e. And I replace that x with an x squared plus 1 plus 7 for e to the x squared plus 8. We can see both of those. There we go. Okay, great. Yeah, that fits nicely. All right, let's check these. So our x here is x squared plus 1. On Desmos, when you're typing in exponents, so right now here, I need to put parentheses for that x plus 7. I need to put parentheses for x plus 7. Without parentheses, it'll put the x below. It'll pull it out of the exponent. And let's see, our answer for the first composition is e parentheses 2x plus 14, and then out of the parentheses plus 1. And our answer for g of f is e to the x squared plus 8. Okay, so let's see here. Let's zoom out a little bit. There we go. Okay, so now we can see our blue graph here is exponential, or blue. Wow. Blue is exponential, purple is quadratic. We got a parabola here. And if we do f of g, that's what it'll look like, a steeper looking exponential. And is that consistent with our answer? Yes, it is. All right, very good. And what about g of f? What about the other way around? Where is it? I don't even see it. Whoa, that is really bizarre. Oh, there it is. There it is. Sometimes you just got to zoom out. There it is, all the way up there. And believe it or not, that is, well, no, it's exponential. So that's crazy. Can't really, there's not much insight there. But did we get the same thing? Yeah, it does match. It does match. So I want to look at the first one again, because that one was at least nice to look at. So there we go. There was the first composition. They both work. They both work. We got them. All right, is this one also going to be small? Let's see. Let's try f of g. F of g is going to be, no, this is not going to be small. Okay, so I got to square all of g, which is 2 to the x plus 4 squared minus 16. All right, so this is going to be like you're foiling again. You do need to foil this. This would be 2x squared is 2 to the 2x, and then plus, ooh, I need to write this down. This is 4 times 2x. You know what? Let me show you this whole thing. I will slow it down for this, because there's a lot of room for silly mistakes here. Let me show you the right way to do this. Show you the right way to do this. So 2x times 2x is going to be 2x squared, which can also be written as 2 to the 2x, right? 2 to the 2x, that's fine like that. And then we have to multiply, well, let me go in order of FOIL. First outer, we got to go outer here. Now we have to do 2x times 4. Now here's the temptation. I know you want to multiply the 2 and the 4, but you can't. You have to keep them separate, right? This is literally 4 times 2 to the x. You cannot multiply those together. Now, when we do the inner, we have another piece just the same, right? So I told you earlier, these would always be identical. And then 4 times 4 is 16, and then we have the minus 16. Okay, so I made this problem so that those would cancel out. You're welcome. So here's what this is going to end up looking like. This is going to be 2 to the 2x plus 8. 4 plus 4 is 8 times 2 to the 2x. Okay. And yeah, you could type that into Desmos. It would work. But I want to take this a little bit further. I want to clean this up a little bit, because 8 right there. So we're doing some algebra tricks right now. That 8 right there is 2 to the 3rd power. So I'm going to replace that 8 with a 2 to the 3rd power. And now I can combine these. When you're multiplying exponential expressions with the same base, you add the exponents. So this becomes 2 to the 2x plus 2 to the x plus 3. All right. That was a good one. That was a good one. So let's pause. We haven't done g of f yet, but there's f of g. Let's check it. Let's check it. A lot could have gone wrong there. So we have x squared minus 16. 2 to the x plus 4 right there. And okay, so that's what these graphs looks like. That's what these graphs look like. The purple is quadratic, the blue is exponential, and the composition of these functions is right there, some exponential looking thing. And let's check, is that consistent? Have we typed in our answer yet? No, I haven't typed it in yet. So we ended up with 2 to the 2x. Oh, I didn't need parentheses. All right. Plus 2 parentheses x plus 3. And reveal. Hey, we got it. Those are the same thing. Very cool, very cool. All right, now we still have to do g of f on this one. We still have to do it the other way around. Do I have enough room for this? Ooh, I may not. So here's what's going to happen. I need some space. So if you want this, screenshot it. Otherwise, bye-bye. All right. Let's now do g of f. G of f. G of f of x would be 2 to the power of x squared minus 16 plus 4. Plus 4. Is that it? Yeah. Do we want to... I mean... You could rearrange this a little bit if you want. This is the same thing as 2 to the x squared times 2 to the negative 16 plus 4, which is the same as 2 to the x squared over 2 to the positive 16 plus 4. But I mean, like, it doesn't really do anything. I mean, you're messing around with properties of exponents there. Honestly, that right there is probably fine. Literally just plugging it in and stopping. I'm going to highlight that one. And then check it. I mean, this one's a no-brainer. I mean, of course it's going to be right because I've literally we've done no algebra. I took f and I plopped it directly into g, and I'm typing it out exactly like that. So really no point here. Whoa, look at that. That's pretty cool. So we have some kind of like smushed parabola maybe, or maybe it's like a mirrored smushed exponential. And yeah, like I said, that's going to be the same there. So that's a cool looking graph right there. So that you get when you, what did we do? We plugged a quadratic into an exponential. That's what that is. The quadratic is on the inside, the exponential is on the outside. Very neat. That was some nice. Let's see all 4 of them. There we go. Look at that. That is a linear. No, that's a quadratic and an exponential with both compositions right there. So pretty cool. All right, let's do it with rational compositions with radicals. Now, I get it. Some of you, these are technically not rational functions because of the roots, but I don't have a better word right now. So rational is used when you have basically a function divided by a function, but they have to be polynomials technically. Most of you probably have no idea what I'm saying, so that's okay. That's okay. You don't have to know these things. Let's just do the algebra. So we'll start with f of g. See what happens here. F of g. G is going to go inside of f. So f is 1 over the cube root of, I'm going to plug in g right now, 2x plus 3 minus 9. 2x plus 3 minus 9. And then, yeah, we're going to rewrite this entire thing just for one little simplification. 1 over the cube root, and then all we can simplify here is 3 minus 9, and 3 minus 9 is negative 6. And that would be it. That would be it right there. That would be it. Let's check that. If you want to type cube root into Desmos, you type CBRT, and it'll pop out a cube root, x minus 9, and then 2x plus 3. 2x plus 3. Here we go. Okay, so we have a linear function and we have a rational looking function. And our answer for the first composition is 1 over CBRT 2x minus 6. So here is the composition right here. Looks like we just had some type of horizontal shift. And then here's our answer, and they check out. Good. Let us go the other way around. How much room did I give myself? Let's see. Let's see if I just throw that down there, if that's enough room. Other way around is going to be g of f of x. G of f of x equals 2, and then I'm just going to plug in this whole thing. 1 over cube root of x minus 9 plus 3. Yeah, again, really there's not a lot of algebra in these ones. We're literally just taking the function and plopping it into the other one without much simplification. If you want to get rid of the parentheses here and plop that 2 to the top, you can. We can do 2 times 1 is 2 over cube root of x minus 9 plus 3 on the outside. And we're not going to try to write that as a single fraction. That's just doing too much. This right here, this is fine. Let's type that in. 2 over, oh, I didn't put my little cube root. I got to put a cube root there. There we go. All right. CBRT, x minus 9. X minus 9 plus 3. All right, here is the accurate g of f right there. Looks kind of like a vertical shift, but it's not exactly the same. And here's our answer, and we're good. We got the same thing. Very nice. Okay. Let's see if something more interesting happens here. I think so. Yeah, something more interesting will happen here. Starting with f of g of x. Notice how we have x in 2 places. We have x in 2 places. We need to put this whole thing right there and right there. That's what we're going to do in the next step. We're going to plop that entire function into those pieces. So that will be 2x minus 5 and then 2x minus 5 plus 1 with the square root. And again, the only thing that simplifies here is negative 5 plus 1. So yeah, unfortunately, we rewrite this whole thing. Rewrite this whole thing. 2 to the x minus 5. And then negative 5 plus 1 is negative 4. Negative 4 right there. Okay. Now, I'm going to write something down. Most of you are not going to understand this. I mean, I don't mean to assume, but that's the answer. That's fine. That's a sufficient answer right there. But you could take this a little bit further by factoring a 4 out of the root in the denominator. Like, why might I want to factor out a 4? Well, because the square root of 4 is 2. But if I do that, that's going to leave behind a 2x to the minus 2 minus 1. And if you don't understand that, that's fine. Just let it go. You don't need to know that. That's just a matter of preference. In fact, it doesn't even look more simplified. It looks bigger. So why would you even want to do that? Let me think though. 4. Yeah. Okay. But anyways, that's extra. That's bonus. You don't have to know how to do that. And then, so f here is x over, for square root, sqrt, x plus 1. X plus 1. And then our g is exponential, 2 to the x minus 5. So we have a rational and an exponential. We have a rational and an exponential. What is our answer? I'll type what I have highlighted, which is 2 to the x. Whoa, other way around. 2 to the x minus 5. 2 to the x minus 5 over sqrt. 2 to the x minus 4. 2 to the x minus 4. Okay, so what do we have here? This is cool. They almost look like inverse functions. But the blue here is exponential, and the purple here is, well, it's not rational. It's I don't know what you'd call this. It's some sort of mixture of square root, radical, and rational. But anyways, f of g of that will look like this little swirly line right here. And is that what we got? Is that what we got? Yeah, we did. So there you go. That's all you have to do. That's it. All right, other way around. Now for g of f, and yeah, this is just another one where it's very literal. It's very literal. There's not going to be any simplification here. You're going to replace this x with the entire f of x. So that is 2 to the power of x over the square root of x plus 1 minus 5 at the end right there. Man, that's not even nice to look at, but that's it. I mean, that would be the answer. It would be redundant to type. I'm not going to type all that in. Here's what it looks like. It looks like that. So you notice that it gets cut off. That's a topic for another video, but that's due to a domain restriction. Something going on with the domain there. But that's what it would look like. All right. So there is all of that. Whoa. There's all of that right there. So those are all four compositions there. What else do I have for us? Yes, I promised that I would be getting to this. Function composition versus function multiplication. So, yes, this is an issue with the notation. Is this open circle means composition. That does not mean multiplication. If the problem wants you to multiply, it'll put a dot, or actually, it might even just write fg of x like that. I didn't think about that while I was typing this. This right here means multiplication, whereas this means composition, right? This is f of g of x, right? So that's the difference. That's what that means. That's what that means. So let's do them both so you can see the difference. So first thing we'll do is we'll do composition, f of, and let me write down the full explanation here. F fog, right? F of g of x, that is f parentheses g of x. All right. And that here would be, well, that would be x plus 5 minus 2, which is x plus 3. X plus 3, just like that. But what if we were doing f times g instead? So this means f g of x. And this time that means we are going to multiply these x minus 2x plus 5. So that would be x minus 2x plus 5. And you would need to FOIL this for an x squared plus 5x minus 2x minus 10. Combine like terms, and you get x squared plus 3x minus 10. So that's the difference. This right here is the product of the functions, whereas this up here is the composition of the functions. So let's check those out. We can still check these with Desmos. We haven't done multiplication in Desmos yet. So let's see. Here's what I'm going to do. We're not doing g of f anymore in this video, I don't believe. If we are, I'll type it back. But I'm going to replace this. No, I'm going to delete this. Delete. I'm going to replace this with f. Will it understand if I put f g of x like that? Will it understand that? No, it doesn't seem to understand that. What if I put a multiplication there? Will it understand that? No, it doesn't like that. Okay, so here's how you're going to have to type this into Desmos. You're going to have to put f of x times g of x like that. Okay, it understands that. Let's switch to our functions of x minus 2 and x plus 5. So these are two lines, two linears like this. And, okay, this is cool. We're going to see some distinctions here. So our answer for our composition is x plus 3, and our answer for our product is x squared minus 3x minus 10. No, plus 3x minus 10. And, oh, this is really neat. I'll explain in a minute. But here's the composition. The composition is a line, and if we check our answer, we got the same line. So our composition checks. What about the product? The product here is a parabola, and did we get the same parabola? We did. There we go. So our product and our composition are correct. But here, I want you to notice that if we compose two lines, we get a line, right? But if we multiply two linear functions, we end up with a quadratic function in x squared. So that bumped up a degree. So that's pretty cool. That's the difference. Let's do one more here. Here I have one quadratic and one linear. So let's start with the composition of this. F of g of x would be 4x minus 1 squared plus 3. And then 4x minus 1 squared, that is 16x squared minus 8x plus 1 plus 3. All of this just to add 3 and 1. 1 plus 3 is 4. 1 plus 3 is 4. So that right there should be our composition. And then let's do our product here. Let's do our product. I need to write it down while I can see. So F times G. Yeah, no, can I zoom out a little bit maybe? Okay, cool. Try that again. F times G of x, that is going to be x squared plus 3 times 4x minus 1. All right, let's FOIL that. If we FOIL that, we would have 4x to the third power minus x squared plus 12x minus 3. And there's no like terms to combine there, so that's it right there. That's it. And let's pull all of these into view. Let's pull all of that into view right there. All right, so our purple here is quadratic and our blue is linear. And when we compose those, we get another quadratic. Let's see if that's the same one we got. And those are the same. Okay, so there's our composition. It's a narrower parabola. And then what about our product? Our product ended up being cubic here, so 4x to the third power minus x squared plus 12x minus 3. Here's the true product, and here's our product. And we got it. Good. Let me hide the composition. It looks like a straight line, but you can see it curls a little bit. This is a cubic function. It's not perfectly straight. And good. So our composition was quadratic, but our product was cubic. So that's a pretty good tell, is if you are composing two functions, but the degree goes up, something went wrong. I mean, don't quote me, I'm not 100% sure, but it seems like that composing will not increase the degree. I don't know. I should try to write a problem and see if that's possible. But anyways, those are those. Composition versus multiplication. So don't mix those up. Last thing here, it's in the video title, is function decomposition. So we're going in reverse. I'm going to give you a function, a composite function, and I want you to break it apart into its pieces. So here's the composite function, h, and I want you to find f and g so that f of g is h. And there's multiple ways you can do this, actually. So one way might be, I'm just going to tell you the answers. There's not a whole lot of explanation here. I could have one function be 1 over x, and then I could have my second function be the square root aspect of it. So it's just you're pulling out the pieces, right? One function needs to carry the reciprocal aspect of it, and then we could give g everything else, the square root, the square, the minus 7. But they can meet somewhere in the middle. Like maybe, for example, maybe f of x doesn't just deal with the reciprocal, but it deals with the reciprocal and the square root. Maybe we make f of x responsible for the square root. That means g of x now would just be x squared minus 7, right? So again, we just kind of pawned off the square root to f. That would be another possibility. Let's see here. Can I fit... why don't I move these down? Well, I don't know. Let's just do this. Here we go. Let's do a third one here. Let's do one more here. So another way we could do this, f of x equals... We could give... Let me think about this. x squared minus 7, x minus 7. I thought there was another way to do this. Let me think. Yeah, there is another way to do this. We could give f the reciprocal function 1 over. We could give it the square root, and we could give it the minus 7. Which means the only thing that f hasn't accommodated for is the square. So we'd have to make g of x the square. But these are all 3 answers to this. All 3 of these. I'm not going to type all 3 of these into Desmos. We'll just finish with the algebra here. But yeah, all of those would work. All of those would work. You have options. Here we have even more options. So how do I want to organize this? Realize that this could be rewritten as 5 times 5 to the 6 to the x minus second power, which would be the same thing as 5 to the x minus second power to the 6th. That could be rewritten as that. Basically, you factor a 6 out of the exponents. But if you notice, 6 is not the only thing you could factor out. We could factor out a 3, which would leave behind 2x minus 4. And so this way could be rewritten as 5 to the 2x minus 4 power cubed. Like that, cubed. Let me make that a cleaner 3 right there. There we go. That's a better 3. And then I could also factor out a 2. I could factor out a 2 from the numerator. What am I saying? This is not a fraction. From the exponent, which would be 3x minus 6. So this could be rewritten as 5 to the 3x minus 6th power all squared. So why do I write these? Why do I rewrite these like these? To show you that there's actually there are a bunch of ways we could decompose this. So the first way we could decompose this is, let's say f of x is the 5 to the x, and g of x would then be 6x minus 12, right? If I just plopped that into that exponent, I would get that. So that's valid. That works. What's another one we could do? Well, let's start using these other examples I have listed. I could do f of x equals x to the 6th power. So now I'm doing this one. I'm doing it like this now. And that means g of x would have to be 5 to the x minus 2. So if I were to stick this into there, I would get this. That's another possibility. Here comes a third. We could have f of x equals x cubed, and then g of x would have to be 5 to the 2x minus 4. So if I were to take this and substitute it right there, I would get that. I would get that version of the compositions, which of course simplifies to the original function. And we'll do one more here. We'll do one more. F of x could be x squared, and then g of x would have to be 5 to the 3x minus 6. And if we substituted, if we compose that with that, we would get that right there, which simplifies to the original. So Good. Function decomposition may have multiple answers. It may have multiple possibilities, different ways you could break these down. But anyways, thank you for sticking around. I hope you learned something, and we will see you in the next one.